It's going to be a really quick video about just how to graph sine and cosine real quick. If you want to learn like what it is and why it works and how to actually understand what's going on, this won't get that job done. But if you just want to figure out how to actually do these graphs before we start translating them around, this will take care of that. These formulas that have parentheses here are how we can find amplitude and period. And just as a quick little reminder, if this, well, I'll do better than that. If that's the sine or cosine graph that I've drawn, draw a good one. That's a sine or cosine graph. The distance from the middle to the top is called the amplitude. Now the wavelength would be the distance from top to bottom, but we're not talking about that today. And one whole cycle is the part of the graph that can repeat over and over and over. So if I were to take this red curve of the graph that I just traced from here to here, and I repeat it over and over, I keep getting the same thing over and over. That's called a cycle. The distance across one cycle, oops, too far. The distance across the cycle from here to here is called the period. On regular sines and cosines, the amplitude is 1, the period is 360 degrees. But we can start changing the amplitude with an A value and changing the period by using a B value. And as we play with those things, the amplitude and period change. So I'm going to graph this y equals sine of 2 theta. All that graphing I just did wasn't y equals sine 2 theta. It was just random graphs I wanted to show to talk about some things. Here the A value is 1, so the amplitude is 1. The B value is 2, so the period is 360 over 2, which is 180. So what we could do is plug in a bunch of points over here that go from 0 to 180, and that would give us a whole cycle. But an easier way to think about this is to start at the origin and go out 1, 2, 3, 4 dots. There's 5 dots total, but 4 spaces that we travel. 5 dots, 4 spaces. I'm going to start at 0 and go out to 180. And that 180 is because that's what our new period is. That's what I found, that it's our new period. Well, then this dot here would be half of 180, or 90. This dot here would be half of that, which is 45. And at this point, I really know that I'm counting by 45. So it's 0, 45, 90. So this would be 135. If I wanted to, I could have made a table of those values. But I don't really need to. I know that the sine of 0 is 0. Like if I plug this 0 into this theta, I'm really doing the sine of 2 times 0, which is the sine of 0, and that's 0. If I plug in this 45, the sine of 2 times 45 is really the sine of 90, and the sine of 90 is 1. And it goes 0 up to 1. It's going to go back down to 0, and down to -1, and back up to 0, and at this point it's going to repeat over and over and over. Two, this one should be here and there. And I can graph my curve. It's going to follow that line. If I can do it better. And that's sine of 2 theta. I can show some more shortcuts though. Here I'll graph 2 sine of 5x. Well, the period is going to be 360 over 5, which is 72. So when I go out 5 dots, there's 0, 1, 2, 3, 4, 5. Oops, I don't want to do 4 dots, we need that 5th one. Well, my last point is 72 degrees, so this is 36, so this is 18, and now I'm counting by 18, so that's a 54. The amplitude is 2. So I'm starting at 0, sine functions start at 0. but now I'm going to go up to 2 and down to 2. And you can kind of start thinking in patterns. Sine goes middle, high, middle, low, middle, high, middle, low. So middle, high, middle, low, middle, high, middle. I can think about I missed one somewhere. It's dust between here. Think about this curve. So I can think about high, middle, low, middle, high, middle, low, middle. And there's my other half. And if it was a cosine function, it would have started high instead of starting middle. Cosine would have started way up here, and then it would have gone middle, low, high, middle, high, but I'm not going to worry about graphing that because that'll confuse you. Finally, we can do the opposite. If you're given a graph over here, well, the period is from here to here. So the period is 120. Which means the b value is 3. The amplitude is 2. And we know it's a cosine function because it's starting at the point 0 something. It's starting high, which means it's cosine. So this is going to be y equals 2 times the cosine of 3 theta, or you could say 2 times the cosine of 3x. These will get more complicated as we start moving it around, but that's a good place to start.